Hi, this is Jeff from the Ozark Mountains in Missouri, USA. Well, today we're going to take a look at the cartridges that were available back in the day for the TI-74 and the TI-95. Now, the TI-74 is a basic programmable pocket computer, and the TI-95 is a similar form factor, but this is a keystroke programmable calculator. I'm not normally big on keystroke programming, but this one actually works really well. I like it. Back in the day, you had the choice of an 8K RAM cart, a handful of ROM carts that TI put out, and then they came out with an EPROM cart and a flash cart. So we'll take all four apart to see what's in there, and we'll see how to replace the battery in the RAM cart, because this one needs to be replaced. Amazingly, it still works. I've copied all the contents of this one off of it already. So without further ado, let's get started. Thanks to PCBWay for sponsoring this video. Be sure to check out their Christmas 2024 specials up to 50% off. They have PCBs, 3D printing, injection molding service. They do CNC machining, sheet metal fabrication. They also have a thriving maker community where you can share projects and check out what other people are doing. For your next project, head on over to PCBWay. Bit of a different camera angle here. Let me know how you like it. So we have our TI-74 here with a cartridge in it. This is a new aftermarket banked RAM cartridge. We'll have more on this later. The original cartridges are like that, and they just slot in there like so. And all of them look the same. This EPROM cart has a little different layout than the rest of these. Now, I understand the TI-74 and the TI-74S variant were very popular in Europe, and they are used by a lot of insurance companies like, get that right set up for you, VGH. And you might just be able to see there the number of labels that are on here. I think there's 4 different labels. So a friend of mine has this same VGH cart from 1991. This is the 1999 version. Laban, that's life. So this is life insurance. And I think there was one other one on there. He got the instructions with his, which I'll pop the picture to that up here. I think on this EPROM cart, you're supposed to be able to pop this little window here out, but I can't do that without destroying it, so I'm not going to. We'll just pop the whole thing apart. And we'll take these apart, maybe start with the ones you're most likely to see, the ROM cart and the RAM cart. We'll figure out what battery that is in there. And then we'll pop apart the EPROM and flash carts to see how those are made. But that's probably best done from overhead. Okay, I found a document online that described opening these, and the guy wasn't sure what to do, and he pried this metal off of here, and he pried the sticker off, and it sounded terribly complicated. And I found you just take a spudger with a little hook on it like that. You pop down in that side. You could probably hear it go boink there. Yeah. But that got that side popped loose. Putting the hook part down, pop that in there like that. And I found these RAM carts come apart easier than the other carts. And then we have a little, what looks like a foil pouch in there, and you can just see the connector says TI made in Japan. And then you've got to hold your mouth just right to get that out. And this is the top of the cartridge with the printing on the connector. And then we've got this foil pouch, which is just a shield that is wrapped all around the thing as a little blanket. And there's a little spring in the bottom here that presses on that metal plate, which presumably grounds inside the machine. And if we unwrap this, I've already had this one unwrapped before, like that. we have our ROM. Oop, blurry. There we go. Okay. So this is a just a ROM. It's actually quite a slow ROM. We had some problems trying to read this on an external device because it's so slow. I'll put a link to the data sheet in the description. And the connector, it's marked as an HL61023-15DJ711. Evidently TI had these custom made, and they chose to put the female connector on the cartridge, which takes up, you know, a third of the available real estate, rather than on the computer for some reason. And the card edge connector used in the computer is just HASL, high air solder layer. It's not gold-plated contacts, so they can get corroded and cause problems. So this is a pretty straightforward pinout. There's only one control signal in here. There's A0 through A15, even though this is only a 32K ROM. There is a chip enable, 5 volts ground, and there's an extra 5 volt line that's used as a battery backup for the RAM cart. Put these back together. We want to go. It's always hard to get this started. About like that. Make sure that's wrapping around there right. I got it a little too far up, about like that. Like that, and like that. And we have our little board burrito. And there's a little nub on the back here, a little catch. You guys are probably getting out of frame there. See, to get this back in there, you've got to hold your mouth just right, pop it down in, and you notice these little things here. These are awfully easy to break because there's not a lot of material there. So on these, I found you can pop the tail end down in first and just go like that. Put your carts back together. No muss, no fuss. This RAM cart is the same way. We'll do the hooky end down here. Give it a little twist. Hooky end down. Little twist. Sometimes you've got to walk that all the way around. There we go. The connector end always wants to come out first. There we go. So there's a RAM cart. It looks just like the ROM cart. I wonder what would happen if I put a little crease there right where that... Oh, I should have thought of that before. Make it easier to line up. Same way we unwrap the metallized mylar burrito, or that just might be some coated aluminum. I'm not sure what that construction is. Unwrap that, and that looks a little bigger than a CR2032. A little thinner too. So I'll get some alcohol and we'll clean that sticker off of there. And of course we got glue boogers everywhere now. Okay, this says it is a CR2430. And we could have figured that out by measuring it. Made by Eveready in Japan. So these little coin cell batteries, the first number, 24, is the diameter in millimeters. So it's 24 millimeter diameter. 30 is the thickness. So 3.0 millimeters, 3 millimeters thick, 24 millimeters in diameter, and it has a if you can see it just there, that is the contact for the negative side, and just there for the positive side. And I do have a battery welder, but I don't think I could manage to pry these guys off of here and get them welded on the right place. So I'll take some measurements of this and locate the right battery. I'll put the information up here on the screen and in the description. And through the magic of television, we'll come right back and swap this battery out. Well, a quick 2 weeks later, thanks to slow shipping and my inability to actually click the order button after putting things in a cart, I got this battery from Jameco. It has 3 leads here, here, and here. It doesn't quite line up with the original. I think it can be made to work. But I also need to order some stuff from Mauser, so I got this battery, which is, as you can see, just like the original. So we'll use this one, and I'll save this one for another project. And of course that means we need to get the original one off of there. So I'm going to first add some solder. I'll suck that solder off of there. First, I'm going to make sure the tip of my desoldering iron is clean here. Oh, it is not. Okay, it's clogged up. I'll clean this and be right back. Okay, I wound up putting a new tip on it. It's a little larger than I'd like for this job, but it should do it. That other one is so plugged up, I'm probably going to have to drill it out to try to clean it. Well, gosh, almost dropped the soldering iron in my lap. Okay, I'll do this a different way. I'm going to put my finger under the battery like that, heat up this joint, and just pull that pin out. We'll do the same for this one. Here we go. Okay. Now we'll clean out the holes. Now, dummy. I was desoldering a diode, not the hole where the battery went. You still can't see that. Sorry, gosh. It's too early in the morning. I'm doing terrible at this video. Okay. Now, old battery out. New battery. Which went in this orientation. Notice how they put this little plastic strip here to keep the battery from shorting out against these 2 diodes on the side. Okay, there and there. Okay. Now our board is resting on the battery. I don't know if I can zoom in anymore for you. Oh, that's a little better, isn't it? Okay. Okay. Check it here to make sure it looks level. It does. Carefully trim these pins as flush as I can. And we'll wrap it back up in the burrito. See, we can see the impression of the battery on our burrito. We'll do that one. That one and that one. There we go. Okay, now before popping this back in the case, I'm going to test it. So we'll look at that next. Okay, I've got my TI-74 set up here. I kind of zoomed in as much as I could on the LCD to get you the best picture. I popped the cart in, battery up. It's kind of precarious doing that without the case, but you can do it. And we'll turn on the TI. And if I list, we can see a program in here. And this is the program that I used to test the TI HX1000 printer in a video or two ago. And you can use these RAM cartridges in two different ways in the TI-74. You can use it as a backup of the built-in 8K memory. You can back that up to your 8K RAM cart and then, transfer it again from the RAM cart to the internal memory. And you can also extend the internal memory out to your RAM cart to have 16K internal memory. But the problem is the only way to save it then is to save it out to over the cassette interface or over the disk interface or using the backpack like I showed briefly before. But I'm going to show you swapping to the RAM cart. So we'll use call put 1, and that calls the put auxiliary routine, which takes what's in RAM now over to the RAM cart. See, that only takes a second. This is a very simplistic routine. It just does a dump of what's in RAM to the RAM cart. Very, very simple. Okay, now I am going to do a new, and if I do a list again, you can see there's nothing in there. And then if I do a call if I can spell, call get 1 and list, our program's back. Okay. Now for the real test, we'll do that again. Nothing up my sleeve. Okay. I'm going to turn this off. Try to get this popped out of here. Okay, and in order to take up a bit of time with it out of the machine, I'm going to pop this back in the case. Notice our little spring is back on here. And there we go. It's always helpful to get the back of your burrito in there first. There we go. Got our RAM cart back in its box. Oh, there we go. Slides in there nicely now. We'll turn it back on. Confirm there's nothing in our 8K internal memory. Then we'll do a call get 1. I don't know if you can see the little flashes it does when you do the put and get. And we got our program back. So indeed, our new battery and our RAM actually works. That's good. And that battery was like $3. Not a big deal, not too hard to change. And so it's not too hard to take the card apart once you figure it out. So that's all there is to it. Next up, we have an EPROM cart, and we're going to pull this apart in a similar manner. Put our hooky-doo down in there. And on the other side like that. And I found that these guys are a little more difficult to get back together. And again, you gotta try to pull it out from the connector end. Like that. Okay. So here is our board. It goes in like this. I think I had it flopped around there originally. And you can see the window, which would come to this thing. Oh, I see now that the hook for to release the thing is hidden under the sticker. It would go like that. And then you could pop it out and have access to the erase window. Like so. Okay, so they cleverly applied that sticker to hide how you release the erase window. Okay, and if we undo the burrito, same TI connector, and this is an Atmel 27C256 in a PLCC format. There is a transistor here, resistor, capacitor. I imagine this has to do with the VPP, the programming voltage. And I'm guessing since it doesn't take that programming voltage from an external connector, that this is routed to where the battery backup voltage would come from for the RAM cart. I'll ohm this out and pop a diagram up here for you. But other than that, it's just a standard PLCC EPROM connected to the address and data lines here. The one thing we did find out working on the new RAM and flash carts was that in the TI documentation, A14 and A15 are swapped. So that caused some confusion on our end. So I'm going to put this one aside so I can ring this out and find out where these extra components go. And then through the magic of television, we'll put it all back together. And now the big dog, the 128K flash cart. Same method of disassembly. The little hooky-doo tool like that. Like that. Okay. And these are slightly differently made. Again, that way. And you can see this looks a little crazy because they have an external connector here. And it looks like it might have been set up for an EPROM also, because there's a hole in there for some reason. But the same way, we've got our burrito in here, and we know the connector has to line up with that hole there. And that's a pretty small connector, and as I recall, that is for the programming voltage for the EEPROM, or the flash. This one is not wanting to peel off of there as nicely. So we'll just cut it. A friend of mine reverse engineered this cartridge. I'll put a link to that file in the description. Okay. And I should mention that the EPROM and flash cart belong to a friend of mine named Dan. And I'll get these back together just like they were, Dan, don't worry. Complete with the burrito wrapping. Although this one's not nearly as nice to unwrap as the others. Okay. Let's have to add some of that really thin 3M double-sided tape there to put this one back together. This one's been the most fiddly out of all of them so far. There we go. All in the name of science. Okay. So here we go. Again, the same TI connector. And we have a big flash chip here. There's an AND or NAND chip. There's a couple, there's a 3-to-1 and a 4-to-1 and 1-to-4 decoder. They've actually crammed quite a lot of stuff on this. Couple transistors, it looks like, some capacitors. So basically, this is a banked flash cart, and you write to the, let me start over, this 32K, all the 32K cartridges map in from 7000 in hex to BFFF in hex. To change banks on this, you write to about the middle of that range, 7FF0. It uses bits 4, 5, and 6. They're in a reverse order though. And the first part of each 32K bank looks the same. So no matter which one you start up in, you can figure out where you're at. That's what that looks like. And of course, our connector here for programming voltage. When we made the new carts, it was awfully difficult finding a connector that would work. We found exactly one, and they are quite expensive. They're about half the cost of the bill of materials just in the connector. But we got there. And it's interesting, the cart my friend had could take either two 64K flashes or one larger one, and this is just one large one. And it is, get the old man magnifier here. And it's an Intel part, N28F010-200. I think his used different parts. So we'll have to see if these two carts are exactly the same or a little different. I think they're just about the same. We can compare pics though. In the meantime, I'll get this wrapped back in the burrito and fixed up and use some of that thin 3M double-sided tape to reattach the foil. See, this is only foil on one side and paper on the other, which is different from the other carts. So that's probably why this unwraps so much more difficult. Okay, well, we had a look at our carts. I sent the flash and EPROM cart back to my friend, along with this HX1000. And I don't think I showed you yet that when you bought one of these back in the day, it needed something to fill in the slot for the RAM or ROM cart, so it came with this, which is a blank. It just says RAM ROM, or maybe you can see it right side up there. Kind of hard to see from this camera angle. Anyhow, it just said RAM ROM, and it's quite a bit lighter, and there's no connector in there, which is also going to be very difficult for you to see. But it looks just like the RAM card, and that just takes up space in there like that, so nothing falls in the hole. And you also briefly saw these new aftermarket RAM and flash carts that a friend and I did. I'll do a video about these later. These will be available in the next few weeks. These are interesting machines, the 74 and 95. Well worth getting one if you can get a good price. The 74S seems like it was only available in Europe, and I did find one for a halfway decent price. And it's on the way, and hopefully it'll arrive in the next few days. Then I'm going to do another video about refurbishing these machines, taking care of battery corrosion and things like that. They're not too hard to do. If you have any questions, let me know. I do have dumps of all the available OEM ROMs, and we'll put those on the flash cart. I'll also make those available on archive.org. So if you're looking for them for your original OEM TI flash cart, you can put them on there. Any questions or comments, let me know. Use that comment section down below. Would love to hear from you. Thanks to everyone who helps support the Hey Birt channel through Patreon and other means. It's greatly appreciated. And until next time, bye. I'm going to change the backup battery in this 8K RAM cart. And I have no idea what I was going to say.